talking about angle relationships today, and the first thing we want to talk about is what adjacent angles are. They're basically neighbors. They're two angles that lie in the same plane, have a common vertex and a common side, but no common interior points. They're right next to each other. Okay? Mrs. Turner's classroom and my classroom are adjacent. We're right next to each other. The only thing that we share is the wall that separates us. We don't overlap. Okay, we're just right next to each other. So the same thing is true here with adjacent angles. They're right next to each other. So angle 1 here and angle 2 are adjacent angles. Okay, they're right next to each other. The only thing that they share is this vertex and the ray that separates them. That is adjacent. This is another pair of adjacent angles. This angle 1 right here and this angle 2 right there. Again, the only thing that they share is the vertex and the ray that separates them. Okay? So these angle 1 and angle 2 are adjacent. Here's the things that are not adjacent. If we look at angle 3, which is this angle right here, and angle ABC. Okay, what's the problem with this? They overlap each other. Okay, they're invading each other's space. They're not being good neighbors, so they're not neighbors. Okay, and on this group over here, this angle 3 right here, and this angle ABC, they don't overlap. They don't even have anything to do with each other. They're on opposite sides of the street, down the corner, Okay, so these are non-adjacent, and these are adjacent. Okay. Now, last week we talked about what a segment bisector was. Okay, and we said that it goes through a segment at its midpoint and breaks the segment into two congruent parts. But we also have angle bisectors. Basically, it goes right through the middle of an angle. It creates a pair of adjacent angles that are congruent to each other. Right? So, BD is the angle bisector of angle ABC. Right? And so, these angles right here are adjacent and they are congruent to each other. Right? So, BD is the angle bisector, which creates those two congruent angles. Another pair of angles is linear pairs. Okay? And linear pairs is when you have a pair of adjacent angles whose non-common sides are opposite rays. What do opposite rays form? A line, right? Hence the word linear pair. Okay? So, there are a pair of adjacent angles. Okay? Angle 1 right here. Angle 2 right here. And see how their non-common side forms a straight line. Okay, that is called a linear pair. To me, it's just exactly the way it sounds. Linear pair, together they form a straight line. The two angles together form a straight line. Okay? And if you think about a protractor, okay, if you go from one side all the way to the other, what does it measure? 180 degrees, right? So what do you think is going to be true about these two angles? Then equal 180 degrees. Okay, so that is what a linear pair is. Now, these are not a linear pair. If we look at ADB, which is this angle right here, and we look at ADC, which is that angle right there. Okay, are those adjacent? Are they adjacent? They're next to each other, right? But are they a linear pair? No, because their non-common side is bigger than a straight line, right? Okay, so those are not a linear pair. This first group is, that second group is not. Okay, another pair of angles that we want to talk about are vertical angles. And vertical angles are two non-adjacent angles formed by two intersecting lines. Okay, they have to be created by two lines that intersect. So if I take two lines here and intersect them, they intersect at a point. Creates four angles. Okay? It creates two pairs of vertical angles. Alright? And they're the ones that basically create these with each other, and they share that vertex. So those two angles are vertical, and then these two angles are vertical. Okay? And they have to be created by intersecting lines. they intersect, creates four angles, two pairs of which are vertical with each other. Okay? Now, the thing about vertical angles is they're congruent. Okay? Vertical angles are always congruent to each other. So the blue angles are congruent, the red angles. Okay? Over here is an example of things that aren't. Okay? I have a line here, but these are two different reds. So I don't have any vertical angles here. Okay? Everybody see that? There's no vertical angles. Now, a couple of things that I'm going to assume you know. What's an obtuse angle? Greater than 90 but less than 180, right? The obtuse, obese angle, okay? Acute angle. It's smaller than 90 but greater than 0, okay? So it's an acute angle. And then a right angle is 90 degrees. That's stuff. All right, so in this example here, I want us to name two obtuse vertical angles. Now remember, to have vertical angles, you have to have intersecting lines, okay? So if I look here, I've got a line here, and I have a line here. So my vertical angles have to be created with those two intersecting lines, okay? So give me a pair of vertical angles that are obtuse. BZX would be one of them, angle BZX, and YZW. Okay, so we're talking this angle here and that angle there. And notice, this was 115. This right here was 50 plus 65, which is 115, right? So vertical angles are equal to each other, okay? All right? Now, it says name a pair of adjacent angles. There are numerous adjacent angles here, okay? I'm going to give you an angle. Let's take this one right here. And I want you to name an angle adjacent to angle XZW. What'd you say? T? T. Oh, yeah, TZW. Okay, good. So he said this one right here, right? Okay, good. So angle TZW, there's one. Okay, give me another one to this side. BZX. Okay, this one right here. Good. Okay, BZX. Right. Let me give you a different angle this time. How about this angle YZT and what? BZY would work? Okay, good. Angle BZY. And there's numerous ones. Okay. Huh? Yeah. Okay. So, remember what I said about vertical angles? They are congruent. So, what relationship angle 1 and angle 2 have? They're congruent. What's my other pair? 3 and 4. Right? Okay. Remember that linear pairs, their angles add together to equal 180 degrees. So the measure of angle 5 plus the measure of angle 6 equals 180 degrees. So vertical angles are equal, linear pairs add together to equal 180. Alright, now these next two terms, I think you know, but I don't know, maybe you don't. Complementary angles, those are two angles whose measures have a sum of 90. Alright? They can be adjacent or not. Alright? If you look at this picture right here, do you see how it's got that little box in there? That tells me that that is a right angle. What's a right angle measure? 90. So I can see that the measure of angle 1 plus the measure of angle 2 equals 90. Okay? That means that those are complementary. These are adjacent complementary angles. Okay? And if I showed you this right here, if I showed you this right here, and there wasn't a red box, could you assume that that was right? Just because it looks like it. You have to be told that it's a right angle somehow, some way. Okay? These aren't adjacent, and there's no right angle box, but what do we see about their measures? They equal 90. So they're also complementary. So angle Q plus angle Y measure 90. These are non-adjacent complementary angles. Okay. Basically, to be complementary, they have to add together 90. Then we have supplementary angles. And supplementary angles are two angles whose measures have a sum of 180. Okay? These are just a linear pair, right? We know that the measure of angle 1 plus the measure of angle 2 equals 180. These are adjacent supplementary angles. Okay? Here, these aren't a linear pair, right? But we look at their measures and they're 180 degrees. So the measure of angle B plus the measure of angle Q equals 180. So these are non-adjacent supplementary angles. Okay. Another thing that you might see is that it might say that instead of saying they're complementary, it might say angle 1 is a complement to angle 2. In this case, here, angle 1 is a supplement to angle 2. That might be another thing. That's still, if something's a complement of something else, that means they're complementary. If something's a supplement to something else, then that means that they're supplementary. Okay. Alright, let's look at this example. Find the measure of two complementary angles if the measure of the larger angle is 12 more than twice the measure of the smaller angle. Okay, so what kind of angles are they? Complementary, right? So that means you've got your first angle and your second angle, and together they equal 90, right? Then it says the larger angle is 12 more than twice the smaller. The larger angle is 12 more than twice the smaller. What's the smaller? Do we know? We don't, so what do we let the smaller be? X. We let the smaller be x, and then the larger is 12 more than twice that. 2x. Back and read it. Okay? The larger is 12 more than twice the smaller. Okay? It's always important to go back and read what you come up with. So you've got your smaller, your larger. They add together to equal 90 because it says they're complementary. Okay? If they were supplementary, then they would equal 180. Alright, so let's solve this. We end up with 3x plus 12 equals 90. We're going to subtract 12 from both sides, so we get 3x equals 78. Divide both sides by 3, and I get 26. What does that represent? That represents smaller. You are going, well, you could do one of two things. Hold on, let me write this down. Okay? We know that they're complementary, so if one of them's 26, we could just do what? Subtract from 90, because together they equal 90. So 90 minus 26, which is what, 64? So that makes the larger angle 64 degrees. But I also could take the smaller and multiply it by 2 and add 12. Okay, because the larger is 12 more than 2 times that. So you could do it either way. Okay. Any questions on what I did there? Okay, here's another definition. Perpendicular lines. Those are lines that form 4 right angles. So basically they intersect, and when they intersect, they form 4 right angles. If they form 1, they form 4. Okay? This is the symbol right here for right. Okay? This is the symbol for perpendicular. Okay? That means perpendicular. You need to know that. Because in your homework, they might give you something like this right here. Line WY is perpendicular to line XZ. You should immediately be able to draw a picture and show that they create a right angle because it touches the perpendicular. Okay? You know that if it tells you this. So that's another way to know that you have a right angle, is that you're told they're perpendicular. Okay. Find X and Y so that BE and AD are perpendicular. Okay, so if BE and AD are going to be perpendicular, they're going to have to create what? Right angles. So there needs to be a right angle here and a right angle here. So I've got to figure figure out what the value of x and y need to be in order to make that happen. So what's going to have to be true in terms of my angles represented with x? Say what? What's going to have to be true about my angles that are represented with an x in x distance? They equal to 90 degrees, right? So I would have to do 6x minus 4 plus 3x minus 5 equals 90. Okay, so that gives me 9x minus 9 equals 90. Add 9 to both sides. I get 9x equals 99. And so x is 11. So that takes care of my x's, right? If x is 11, then I'm going to have a right angle there, right? What's going to have to be true about 12x minus 10? It's going to have to equal 90 also. 12x minus 10 equals 90. What? Oh, that's what I said. I wrote y, but I said x. You think 12y minus 10 equals 90. Okay, so 12y minus 10 equals 90. Add 10 to both sides. So I have 12y equals 100. 100 divided by 12. It's going to give you a decimal, which is okay. You could reduce it, which would be what, 25 thirds, or you said 8.3 repeating, which is the same thing as 8 and 1/3. I was thinking of those answers. You always know that 0.3 repeating is a third, right? Okay. All right. So if x is 11 and y is one of those three answers, 25 thirds, 8 or 8 1/3, then you're going to have right angles. All right. Last little question. Determine whether each statement can be assumed from the figure below. LPM and MPO are adjacent angles. Yes, that would be true. Go back to the definition, okay? They're next door neighbors. They share a vertex and a ray, but they don't overlap or anything. So yes, they do. Okay, it might ask you to justify, which again, you go back to the definition. Okay, OPQ and LPM are complementary. They don't make a 90-degree angle. I mean, they could both be 45 because they are congruent. You see how they've got the congruent mark right here? But there is no indication of what their measure is. So you cannot assume that they are complementary, okay? So the answer would be no. There is no indication of their measure. Okay, last one. LPO and QPO are a linear pair. They're adjacent, and they're equal 180 because they're not common sides or opposite rays. They form a straight line, right? Okay. All right. So lots of things that we learned. Okay. You need to know if I say adjacent angles, you should know what that means. You should see two angles that are neighbors right next to each other. If I say linear pair, a picture that should pop into your mind. You should say together they equal 180. Okay. If I say perpendicular lines, immediately you know two lines intersect with 4 right angles. If I say vertical angles, we should say those are created by lines that intersect, and the vertical angles are congruent. So you got to know these terms.